Hey everyone, welcome to a brand new explainer where we're tackling the absolute ultimate question for anyone jumping into a tech career right now. Like, how do you actually get hired at a top-tier company today? Well, we are diving deep into the insider's playbook, and we're drawing our insights directly from Anders Hejlsberg. If you don't know him, he's a lead architect at Microsoft and the genius creator behind C# and TypeScript. Honestly, if you want to not just survive the current tech landscape, but completely thrive in it, you absolutely need to hear this.
Right off the bat, let's just address the giant existential elephant in the room. Will AI replace software engineers? Look, there's massive anxiety right now around vibe coding and just the sheer sweaty-palmed fear that AI is coming for all the developer jobs. And you know what? It's a completely valid fear. But as we'll see, it's also largely misunderstood.
Okay, let's dive into this. Here is our playbook. 1. Why AI will not replace coders. 2. Mastering fundamentals over shortcuts. 3. Essential computer science topics. 4. Building open source on GitHub. And 5. Focusing on long-term growth.
Section 1. AI will not replace coders.
Anders actually made this incredible point. He says AI is not going to innovate. Someone has to design the CPU, the operating systems. Think about it. AI has digested literally millions of rote, basic to-do list apps in its training data, so of course it can effortlessly spit out surface-level code. But the actual business logic, inventing the underlying complex systems that actually drive the tech industry forward, AI simply isn't going to do that. It doesn't have those spontaneous shower thoughts that lead to massive breakthrough innovations. That's on us.
This brilliantly illustrates the real divide here. AI's true domain is generating the boilerplate code, writing tests for pull requests, and just handling the tedious grunt work. But your domain, the human mind, that's innovating. That's designing the core architecture and devising really complex solutions, like sharding data structures so a startup can actually scale up. AI is an incredible accelerant for sure, but the fundamental architecture, that always comes from you.
Section 2. Master fundamentals over shortcuts.
This brings us to what is easily the biggest mistake beginners make when they're rushing to learn. They get trapped in what's called the syntactic veneer. Basically, this happens when you learn the surface-level commands of a programming language, but you have no idea about the deeper mechanics of why it actually works. If you're just memorizing syntax, you are competing directly with AI on its home turf. And spoiler alert, coding shortcuts like that simply won't survive this AI shift. You've got to dig deeper.
So the crucial point is that you need to master deep semantics. Ask yourself, what is a variable? Really? How do arrays actually function under the hood? What exactly is a data structure? And how in the world do pointers work? Anders emphasizes that once you truly grasp these deep concepts, the specific programming language you end up using almost doesn't matter. The language is really just a thin layer on top of these fundamental semantics.
Because ultimately, true abstract thinking comes from understanding the semantics, not the syntax. Deep comprehension is what allows you to zoom out, think abstractly, and design vastly better systems. Without it, you're stuck at that surface level, just constantly asking, what do I type next, instead of truly understanding, why am I building this in the first place?
Section 3. Essential computer science topics.
So is a computer science degree actually worth it? Man, practically every beginner asks this. Interestingly enough, Anders grew up in Denmark in the late 70s, and get this, the engineering school he went to didn't even have a computer science department yet. He had to learn everything the absolute hard way, entirely by doing.
But actually, because of that grueling experience, he firmly believes a formal education is a massive shortcut. It saves you an immense amount of time. Look at the advantage it gives you. You learn the history of programming, the core principles, data structures, databases, and operating systems. Immersing yourself in these essential topics builds a rock-solid foundation that AI just cannot replicate.
As Anders notes, ultimately, that's where the performance comes from. Small design choices that affect so much. Whether you get a formal degree or you fiercely study these topics on your own, deeply understanding something like how a hash table works is exactly what enables humans to architect highly efficient, scalable systems.
Section 4. Build open source on GitHub. Let's move to how this builds into an actual actionable strategy. This is Anders' absolute #1 piece of advice for getting hired and proving your worth. Step 1. Write a bunch of open source code. Step 2. Put it out in the open on GitHub. Step 3. Use this as your definitive resume. Seriously, there is nothing more powerful than actively demonstrating your ability. Do not let your private projects sit gathering digital dust on a hard drive. Share them with the world. And hey, if you're a beginner stressing out about exactly what to build, don't. It really doesn't matter if you build a game in Unity or a web backend REST API, just start writing. The specific project matters far less than the active practice of building data structures and measuring performance. By writing actual code, you truly internalize how these languages work.
Section 5. Focus on long-term growth. Let's look at the history of C# to really understand what long-term thinking looks like in tech. Anders joined Microsoft back in 1996. And by 2000, C# was officially introduced. The goal at the time was super ambitious. Combine the immense expressiveness of C++ with the incredible ease of use of Visual Basic. And today, it continues to see widespread global use because it was built from the ground up as a lasting architectural marvel.
Now, what's really interesting about this number, 25, is that C# has survived for a quarter of a century in a brutally fast-moving industry. Why? Because of its brilliant foundational design. It gave first-class treatment to structural concepts like properties and events. It solved real problems for developers, rather than just cashing in on whatever temporary coding fad was popular at the time.
We see this exact same long-term thinking with TypeScript. Years ago, a team at Microsoft was writing an enormous application in JavaScript. JavaScript is a true cross-platform solution, which is great, but man, it is incredibly hard to scale for massive apps. So, Anders and his team created TypeScript. They added a robust static type system and incredibly powerful tooling. Because when your project scales up to 1 million lines of code, you inevitably need deep structure to stay productive. You can't just wing it.
So this brings us to our final thought. Will you rely on fleeting, syntax-level shortcuts, or will you build the deep foundation needed to actually command the AI of tomorrow? AI is absolutely going to handle the grunt work. There's no stopping that. But the future? That belongs entirely to those who understand the core architecture. So master those deep computer science fundamentals, build your projects in public, and make yourself entirely irreplaceable. Thanks so much for joining me for this explainer, and keep building the future.